The content that we are going to cover today, it is regarding CCIE Enterprise Infrastructure version 1.1. And there are several sections, there are several things that we have here. One, we have like our traditional routing and switching in this. Then we have software defined networking, which has like SD-WAN and as the access part. Then we have, majorly we have our automation and programming. So the entire CCIE Enterprise Infrastructure will have like these three main things. In the routing switching, we will have the topics regarding routing, switching, transport technology such as MPLS, infrastructure services such as like NTP, syslog, DHCP, infrastructure security concepts as well, basically. So the traditional routing and switching, this is going to cover 60% of the entire content. Then the software defined networking, it is going to cover like 25% of the entire content. And the automation and programming is 15% of the entire content. That is also mentioned here in this official CCIE EI 1.1 blueprint. We'll talk about it in a moment. So if you are preparing for the lab exam, or if you will prepare for the lab exam later on, you will have to focus on these three main parts: routing and switching, SDN, and the automation and programming. What we are going to cover, what we are going to start today, it's going to be like routing section specifically. So we'll talk about from the routing and switching, we'll talk about routing and like we'll talk about services, we'll talk about like anything other than software defined networking, automation, programming, and switching. Anything else that is left, routing, the security services, the DHCP, DNS, NTP, whatever other services are there, we are going to cover like all that. Basically, we'll make sure that except this software-defined networking, automation, programming, and the switching, everything else from that official blueprint gets covered completely. So we are going to focus specifically on the routing. And not only we are going to focus on the CCIE Enterprise Infrastructure routing part, the lab exam, we are also going to take a look at the NCORE exam. Basically, whatever things we are going to cover, those things will include all the topics that we have in the NCORE regarding the routing again, routing and services. So whatever things we have in the NCORE exam regarding routing, again, same like EIGRP, OSPF, BGP, multicast, some MPLS, everything regarding the routing, we are going to cover from the NCORE exam as well. So you will not require like any separate training for the NCORE by the end of our routing content. Same when we talk about switching, we will complete the switching section from the enterprise infrastructure and the NCORE exam, so that you don't require like any additional classes for the switching afterwards. So our content is going to focus on the topics of both CCIE Enterprise Infrastructure Lab exam and the NCORE exam. NCORE is more like the written exam. It's more like the written exam for the lab exam. You have to pass NCORE, then you can attempt, then you can book the lab exam. So NCORE exam contains some topics as well. Routing, switching, software-defined networking, automation, programming. There are also some security topics and all. So we are going to specifically focus on the routing section at the moment. In our rest of the topics.
So when you said Encore, you're talking about CCNP Encore, right?
Yes, correct. CCNP Encore, basically.
So once you have, okay, yes, sir. Sorry, go ahead.
No. So I was just saying that everything regarding the CCIE Enterprise Infrastructure, that NCORE and Enterprise Infrastructure NCORE, we are going to Enterprise Core exam, basically, we are going to complete from our content point of view as well, so throughout the content.
So with Encore exam, you just cannot take your CCIE lab. You still have to write your CCIE written exam, right?
This is the CCIE written exam more like. So if you want to attempt the lab exam, you have to pass the NCORE, and then you can just book the lab exam directly. There's no separate written exam. Earlier, what used to happen, we used to have a written exam and the lab exam, but now this written exam is the problem in this approach was like let's say someone gets written certified. He didn't used to get like anything, like he was just routing and switching written certified. There was not like no certification given to that candidate, like anything like that. So what they did, they changed the approach a little bit. What they did, like, okay, what you can do now, you can take the Enterprise Core exam, which is the NCORE exam, and then you have an option. After NCORE, you can go for several concentration exams. Those concentration exams, such as like SD-WAN exam, those like ENARSI, NRC exam, like some additional exams, basically like automation, design, some additional exams. One of these additional exams you can take, and you will be CCNP certified. If you pass the ENCORE exam, and if you pass one of the concentration exam, then you will be CCNP certified. And if you take the ENCORE exam and you take the lab exam and you clear that lab exam, then you become the CCIE certified. So this ENCORE exam is more like a prerequisite for both CCNP and the lab exam actually now. So one must pass the ENCORE exam before they can proceed to the CCIE lab exam. And if someone wants to get the CCNP, they also need to go for the ENCORE exam as well as the one of the concentration exam. There are many concentration exams. You have to pass just one of the concentration exam like SD-WAN, NRC, or anyone.
Yes, sir. Understood. Thank you.
So what we will be focusing on, the content of routing specifically from the ENCORE exam and the CCIE Enterprise Infrastructure Lab exam. I will also say that if you already have gone through like the NRC training, which is specifically focused on the routing, those topics will also get revised. However, it will be assumed that you have some level of understanding of routing concepts because, of course, like it's a CCIE level training, like it's not like a beginner level stuff. So some basic assumptions will be made, some basic prerequisites are there, basically that basic routing, basic IP addressing, something, some talk about it, like what things you must already know before you can take this training. Basically, what I'm trying to say is that it's not for a complete fresher. It's not like you just have gone through the CCNA and just directly jump to the CCIE. You will find it a little bit hard to go through all the things that you must know before we begin our training. But anyway, from the content perspective, we'll be talking about the routing from the ENCORE and the lab exam. And I believe I say that the routing stuff from the NRC, like that will also be pretty much revised and complete. So everything like regarding routing, you will in the enterprise routing, basically whatever content they have in their certification exam. For that, like you will not need to go for like any other training after the completion of our classes. It will take time, but after completion of our routing classes, we will no longer require like any other like routing training for the ENCORE, for the NRC, or anything. It is going to be like completely done from the routing. The content is quite vast, actually. I would say it will take like a lot of time. First, let me show you what things we are going to focus on. Then I will talk about the days, how much time it will take to complete this training. Specifically routing, I'm specifically going to talk about the routing now. So as you can see, this is official Cisco website, CCIE Enterprise Infrastructure version 1.1, practical exam, lab exam. And the whole content of the CCIE lab exam is divided into 5 modules. One is network infrastructure, software-defined networking, transport technology and solution, infrastructure security and services, and automation and programming. So this part, and this part is 60%, which is more like routing and switching, 30%, then 15%, then 15%. And then this software-defined networking, by the way, is 25%. And the automation programming is 15%. So overall, like routing and switching, software-defined networking, and automation programming, these are the 3 main things that we have in our enterprise infrastructure lab exam. So what we will be focusing on is specifically, if I expand this like this unit number 1, if I expand this exam topic, the very first thing is switching campus, which is like switching. This is specifically regarding switching, which we will talk about later on someday in the switching section, not in the routing section. So this is specifically switching, by the way. So this is like switch administration, the layer 2 protocols, the VLAN trunk, then EtherChannel is penetration. Very limited content, by the way. Very limited switching content that we have here. Not a lot of things regarding switching nowadays in the content. So very limited content, but RSTP, EtherChannel, VLAN trunk, some L2 protocols, and basic switch administration. This is a switching topic, which will be covered when we talk about switching later on. This is not what we will focus at the moment. We will focus on the routing concepts. So 1.2, the routing concepts, like what is AD, static routing for unicast, multicast address family, the policy-based routing, the VRF-aware routing. So what we have to talk about, actually, we have to talk about routing. We have to talk about routing for IPv4 and IPv6, IPv4 unicast, multicast, VRF, IPv6 unicast, multicast, and VRF. And also later on, we will talk about VPN address assembly. So VPN v4 and VPN v6. This much stuff regarding the routing we have to talk about. We have to talk about the routing protocols: BGP, EIGRP, OSPF, static routing for IPv4 unicast, IPv4 multicast, IPv4 VRF, IPv6 unicast, IPv6 multicast, IPv6 VRF, IPv4 VPN, basically VPN v4 and VPN v. Then we had to talk about like route leaking. We had to talk about VRF. We had to talk about like the distribution, authentication, the VFD, the MTU, basically general routing concepts, basic routing concepts we have to be aware of. What are the we'll talk about throughout the content about these things one by one. But AD, static routing, policy-based routing, VRF aware routing, and all that distribution. This is the basic stuff that we have to be. And then from the routing protocol point of view, EIGRP, by the way, this is EIGRP. This is how much you should know regarding EIGRP from the lab exam point of view. We will talk about EIGRP recency, best path selection, the terminologies that we use, the general operations, what is EIGRP graceful shutdown, stuck inactive, basically all these things we will talk about one by one. Then classic EIGRP, named EIGRP, how in EIGRP we can optimize the convergence, the failover, all that thing. What is this leak map and all that? So basically EIGRP for both IPv4 and IPv6. EIGRP for both IPv4 and IPv6, unicast, multicast, VRF and all that thing we have to. Then OSPF for IPv4 and IPv6, OSPF adjacencies, address families, different types of network, point-to-point broadcast, point-to-multipoint and all, area types such as stub, totally stub, not so stubby, preference, intra-area, inter-area, general OSPF operations, graceful shutdown, TTL security, OSPF metrics like cost, throttling, like how can we fine-tune the OSPF operation by changing some timers, not the hello timer, not the dead timer, but some other timers such as LSA throttling, SPF throttling, what is the stub router, what is this prefix operation. These are general things that you must know regarding OSPF version 2, version 3, IPv4 and IPv6. So that's what we will focus on. We'll talk more about it, but we will focus specifically on this particular. And then the BGP, the Border Gateway Protocol, the IBGP, the ABGP, peer groups, templates, timers, dynamic neighborship, manual neighborship, AS numbers, best path selection, algorithm, path attribute, how the load balancing is there in the BGP, how can we influence the BGP best path selection using path attribute, what is this conditional route advertisement, outbound out filtering, communities, multi-homing scenarios, additional AS path manipulation techniques such as local AS, allow AS, remove private AS, regular expressions and all that, route reflector, confederation, aggregation, AS set, other features such as software configuration, route refresh. This is the part that we have to focus on. Apart from that, like we will talk a little bit more about it, but this is the part that we have to focus on specifically from our BGP content point of view. Again, for both IPv4, IPv6, for both IBGP and BGP. So this is all going to be unicast, IPv4 unicast routing, IPv6 unicast routing, and then we'll talk about multicast, layer 2 multicast, layer 3 multicast. What is this IGMP protocol? What is this PIM protocol? PIM sparse mode, sparse dense mode, source specific multicast, IPv4 anycast RP, MSDP, for example. So IGMP and PIM, very limited content of the multicast, but IGMP and PIM, whatever is relevant to our discussion, we will talk about it. IGMP and protocol independent multicast. It's not like complete multicast, but it is what is relevant to our content. So this is what we will focus on specifically from our routing content point of view. This will be covered, by the way, in the route. So these are the main topics from the unit number 1. So except for this 1.1, everything else we will cover. We'll talk about like everything else except for this 1.1. Switching is dedicated discussion. Later on we'll talk about it, but this is later on. So ignore it. Then SDN we will not talk about. SD access, SD-WAN. There is a dedicated content. There is a dedicated a batch course for the SD-WAN, SDA. So we are not going to talk about it in our routing, by the way. Then we will move on to the VPN. We'll move on to the VPN technologies. We'll talk about like what is this what is this GRE, what is this DM VPN, what is this MPLS based VPN. Again, we don't need to worry about the whole MPLS service provider. That is, we have to focus on the MPLS from our content point of view, and we have to specifically focus on this thing called L3 VPN. L3 VPN for IPv4 and IPv6. We have to specifically focus on this like L3 VPN. However, we'll also talk about the L2 VPN services such as ATOM, any transport over MPLS. But this transport technology and solution content is very limited, where we have talk about the GRE, we talk about VMVPN, IPsec, and MPLS. 15% of the whole content. There is a dedicated unit when it comes to the exam, where they ask questions regarding this MPLS and all these technologies. So we have to, in fact, we have to talk about these things. So we will cover this in our content, and then we'll move on to the infrastructure security and services. This is also what we will cover in our content, such as control plane protection, CAP, control plane policing and protection, AAA. We will talk about some AAA configurations. This we will not talk about. This is part of switching, by the way. This is switching content, so it is covered in switching. Then router security features such as URPF, access list, IPv6 access list, we will talk about. IPv6 infrastructure security features, we will talk about RA guard, HCP guard, and all that. But these topics will be covered at the very end. Once we are done with our routings, content, and all, then we will talk about all these content. And then so security and services, and then the management, device management, like console, VTY, SSH, RESTconf, NetConf, SNMP, syslog, system management we will talk about. The quality of service, the classification marking, how can we configure policing and shaping, how can we configure like queuing, all these things regarding the KVS, quality of service also we'll talk about at least 4 days, at least 1 week of the class will go in the quality of service. So we will talk about quality of service in as much detail as we can, focusing specifically on our. And then infrastructure services such as this part, this is covered in, by the way, this is covered in switching. This we will talk about, but this is covered in switching, HSRP, VRRP. There's no GLBP anymore, but this is we cover in switching. This we will cover NTP, DHCP, NAT, SLAs, tracking, span is covered in switching, but we will talk about embedded packet capture and all that thing. So network optimization, network operations, monitoring services, and all that. Basically, this part, this infrastructure security and services, this we will cover at the very end of our content. Once we are done with all the routing topics, then at the very end we'll talk about infrastructure security and services. And everything that is mentioned here, except for those things that are already covered in the switching, we will talk about everything other than that. And then automation and programming, no need to worry about it. If some time is left, then I will show you about like EEM. I will show you about the cache shell and all that thing. But this is specifically from the for this. In order for this to know, you have to know about the vManage. You have to know about the DNA center. This is the specific, like we don't need to know about like whole programming stuff. For example, here in this question, they want us to do some API calls. They want us to interact with the vManage, which is the centralized management plane for the SD-WAN. So if you know SD-WAN, then you know vManage. Then how can we interact with the vManage using the API? That we have to talk about. And how can we interact with the Cisco DNA Center, Catalyst Center using the API to talk about? For these topics, for example, for you to know, you have to know about the SD-WAN, you have to know about the SDA. So this can't be covered at the moment. A data format is basically how different types of data format is that it's nothing basically. This can be covered if again by the end of our curriculum, like if some time is left, like if you guys will still be there, we can touch this topic actually, at least an overview. We can touch this topic at least as an overview. And this thing, by the way, is in fact discussed in SD-WAN. This thing is in fact discussed in the SDA as the content progresses. So these things will eventually be completed, but not in our routing section. So this part will be completed here and there, but not right away in our route.
Sir, can you show that one more time, please? The RESTconf and NetConf area?
Yeah, this is RESTconf, NetConf is only in the infrastructure security and services. That is only this one.
Okay.
So this is like 15%, and we have approximately 7 things to cover. So that is approximately is going to be like, this is approximately like 2%. And then there is in that 2%, we have 3 things. And then, so it's a very, trying to say that it's a very small topic, very small. Like we don't need to focus that much on the RESTConf, NetConf, but we will be able to focus on it based on the
Yes.
program. So this is our main content that we will cover. Everything regarding routing from this particular enterprise infrastructure lab exam blueprint. Everything regarding the routing will be covered from here. And eventually it will automatically complete. No need to do. It will automatically complete everything from our ENCORE exam as well. So if I go to the ENCORE exam topics, you can see regarding the routing, for example, for example, like in this architecture, we have switching. What is two-tier architecture, three-tier architecture? What is FHRP, SSO switching part, SD-WAN, SDA? So nothing that we have to cover in our enterprise infrastructure routing content. But previous, the quality of service. Quality of service, since it is part of the enterprise infrastructure, since previous we are going to cover, eventually it's going to cover this particular topic automatically. So that will be done. This will be covered in SD-WAN, this will be covered in SDA, this will be covered in switching. So it will be done anyway. Then virtualization, such as VRF, GRE, it is covered in our routing content. We will talk about the VRF, we will talk about the GRE, IPsec and all. And this Lisp and VXLAN concept is covered in the SDA part. When we talk about the SDA, we will talk in length about the Lisp and VXLAN basically. So this is covered, but not in routing. It will be covered in the SDA section later on. So this will be covered, this will be covered. This will be covered in routing, this will be covered in our SDA. This part basically like server side, some server level stuff. This is covered at the very end. At the very end, once our everything gets completed, this topic, if someone is specifically going for ENCORE, if someone is specifically looking for the ENCORE training, these topics such as virtualization, hypervisor, virtual machine, virtual switching, these things are covered actually at the very end of the content. So once your routing is done, once your switching is done, then at the very end of the content, there are dedicated sessions where we talk about like all these other stuff that is left in the ENCORE, such as this virtualization stuff. So this we will not cover in our routing content. This will be covered, but not in our routing content. Infrastructure L2 switching. This is covered in switching. This completely will be covered. In fact, this also completely will be covered in our routing. So EI, GRP, OSPF version 2, version 3, BGP, policy-based routing, NTP, precision time protocol, PTP, NatPat, HSRP, VRRP, multicast and all. So this will in fact be covered in our routing content, and this will be covered in the switching content. So eventually this section will get completed automatically. Assurance, for example, in the assurance we have ping, trace, SNMP. We will cover that in our routing content. NetFlow, flexible NetFlow, we will cover it in our routing content. SPAN is covered in the switching content. SLA, we will cover in our routing content. NetConf, RESTConf, we will cover in our routing content at the very end. Catalyst Center, DNS Center, it is covered in the SDA topic later on. So basically this unit will also get completed as your entire training is done. This topic will also get completed automatically. Security, such as AAA, such as how can we configure the local username passwords, AAA, we will cover it in our content. Access list control plane protection, we will cover it in our content. The REST-based APIs is basically part of the automation programming. So in the automation programming section, we will talk about this REST representational state transfer REST-based API and how it is secured. Then in general, we had to talk about some security products, the endpoint security, the network security, some general security products such as firewall, what is this threat defense, endpoint security, TrustSec, MASSEC. This is basically in general, we had to talk about some security stuff, which is covered at the very end of the ENCORE content. So if you go for the ENCORE training, at the very end of the ENCORE content, there are going to be dedicated sessions where we will talk about this additional stuff, including this automation programming part as well. This part as well. It is still focused on the Catalyst Center, Catalyst Center, EEM, we will cover in our content at the very end. Some JSON format of data, what is the Python, how can we interpret the Python code, what is netconf yang. So general automation and programming stuff we will talk about at the very end of our ENCORE content. So basically ENCORE will also get covered, but since our content is specifically focused on the routing, we are going to focus on the routing stuff, routing, security, services, infrastructure security and services stuff from this ENCORE. Right. So this is by the way the NCORE exam. This was the NCORE exam. This is the NCORE exam, and then you can take the lab exam, for example. So we already talked about the lab exam and the NCORE exam. So end of the day, you can say that yeah, once your training is done, the entire thing, all the content from the routing point of view will be done from the NCORE and the CCIE routing point of view as well. And since it is like quite detailed, I would say it's not going to be like those I'll be very, very honest here. It's not going to be like those boot camp kind of classes where like you already know about all the stuff, and I just more like revise all the things quickly in like 5 days, 10 days, 20 days. It's not going to be like that. It will take time. It will take quite a long time actually to complete all these content. And how long will it take? I will show you. How long it's going to take, I will also show you. Generally, in order to cover the routing, how much time is basically needed? I will show you. Take a look at this. Take a look at this Excel sheet. How much time will it take to complete the entire routing content? I'm specifically talking about routing. Currently, we are here. Content. We are discussing about the content. We'll talk about the routing in a moment. Then the encapsulation process, the capsulation process, the ICMP, ARP, TCP, UDP, traffic flow, the routing protocol, the algorithm. Basically, this week we will talk about these 4 days. We'll talk about the basic stuff. We'll talk about like when you ping from one machine to the machine, how the packet flows, what is ICMP, what is R, the TCP, UDP, Telnet, SSH, and all that. All that basic traffic flow we will talk about. Then we will start our static routing. So static routing using next hop, static routing using exit interface for the whole network for the specific route, then floating route, default route, NAT. NAT also we'll talk about a little bit NAT here itself. So NAT, PAT, static routing with IPSLA, permanent static route, and different types of NAT. Basically, these like 5 classes. We'll talk about the static routing for IPv4 and NAT. In the topology that we have like we have to configure the routing as well as the NAT stuff. Then EIGRP will take like 1, 2, 3, 4, 5, 6, 7, 8, approximately 2 weeks, 4 days a week basically. So approximately 2 weeks we will talk about the EIGRP, all the EIGRP fundamentals that we must know from the exam point of view, from your production point of view as well. That 5 days, that 2 weeks, basically 8 classes. 8, 9 classes will talk about the EIGRP. Then like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 classes approximately. Approximately 13, 14 classes we will need for the OSPF. 13, 14 classes will talk about OSPF. We will talk about like LSAs, type 1 LSA, type 2 LSA, type 3 LSA, then type 4 LSA, type 5 LSA, type 7 LSA. So will take time, obviously. Approximately 13, 14 classes we will need for the OSPF. Considering that you already know about OSPF, it's like, all these things are basically considering that you at least know a little bit about the IGRP, at least you know a little bit about OSPF, at least you know what is this area, although we will cover it, but at least you know like what is area, what is like EIGRP, AS number. These 13, 14 classes, I will assume that you at least know some basic to intermediate level stuff about the EIGRP OSPF. And once our EIGRP OSPF topic is done, once our IGP, Interior Gateway Protocol, is done, then we'll talk about route filtering, path manipulation, AD, access list, standard, extended, route map. These things basically we'll talk about. 1 week, 4 classes. We'll talk about like access list, prefix list, route map, area filter list, offset list, basically whatever filtering mechanism we can have in as much detail as we can. We'll talk about here in 4 days.
So
and
sir,
then we will
these numbers that are shown like 31, 32, 33, 34, it means days, day number 31, 32, 33.
Yes. So typically like this is covered in 1 day, this is covered in 1 day. So it's like by the end of 34 classes, classes, we will approximately end our IPv4, unicast routing, like static routing, EIGRP, OSPF, and route filtering. So approximately 34 classes for this discussion.
Yes, sir.
And then the border gateway protocol, the VGP. So from 35 all the way to approximately 55, like approximately 20 classes. Approximately 18 to 20 classes I will take for the border gateway protocol, where we will talk about the the BGP, the address families, the best path selection, the path attributes, in as much detail as we can, as focus this specifically on our content. Right? Focus this specifically on our content. From our content point of view, at least this much you have to. At least this much we have to know.
Sir, I have a question.
Yes.
So with this training, do you think we would be able to learn some troubleshooting scenarios?
Yes. So that will keep happening like throughout the content. A general discussion about the regular issues that you might encounter in the production environment regarding BGP, OSPF, PIGRP, some documents and all. That will keep covering throughout the content actually.
Okay, that's good. Yeah, that is my expectation here with this training. Otherwise, I have already taken CCNP complete training from Yadav sir. So,
okay.
And I've been unemployed, and I have filled all the interviews that actually ask the troubleshooting scenarios. So I've been unemployed for very, very long time, like very long time, and
that will definitely get covered. That will definitely by the end of this routing section, you will have that much of understanding of the network that you can easily be able to troubleshoot. Like I will say like medium to small. I would also say like a little bit large network because the content is quite vast. So some general troubleshooting scenarios, the commands, like what things to expect when you face this issue. That thing will keep going on throughout that we will keep covering throughout the content actually.
Yeah, this was my primary
that will definitely it will happen. Definitely.
Thank you, sir.
So approximately 20 classes for our border gateway protocol. 20 classes is more than a month, by the way. So I will say that at least for a whole month, we will talk about one whole month we will have the BGP classes. Then IPv6 fundamentals, the types of IPv6 addresses, the routing for IPv6 like EI, GRP, OSPF, BGP, all the things. So this IPv6 stuff will take some time. Then multicast is basically multicast, IGMP, MLD. Then so few classes for IGMP, few classes for PIM. So we'll take some time for the multicast as well. 7, I believe, like 1, 2, 3, 4, 5, 6, 7, 8 classes approximately for multicast. Again, whatever is relevant to our content, like whatever is there in our content, we will focus specifically on that first. And then here and there, if we can talk about some additional stuff, we will talk about it. But again, so this is the content that we have in our official exam. So we'll focus on that part first. And then here and there, if we can talk about some additional stuff, we will definitely talk about it. But our primary objective is going to be complete everything that we have in our official content. Then the VPN technology, the GRE, DMVPN phase 1, phase 2. So first we'll talk about the GRE, DMVPN, IPsec. Then we'll talk about the MPLS, unicast, the basic MPLS operations, then MPLS-based VPN, L3 VPN. We'll also talk about some L2 VPN, shambling. That's some additional stuff we will talk about, but we will focus specifically on the MPLS L3 VPN. So in the VPN, we will take some time as well. In the VPN also, it will take some time as well. GRE, DMVPN, IPsec, 10 MPLS and MPLS-based VPN. Then QS, 4 or 5 classes for the quality of service, 4 or 5 classes for QS, quality of service. Then we will talk about, once it is done, then we will talk about so in quality of service, we'll talk about classification marking, queuing, then condition avoidance like gap policies, red, policing shaping, all that thing. So like 5-6 classes will require for the quality of service. And so by the end of these 85 classes, your routing stuff will be done. And then whatever additional things are there, like control plane protection, AAA, time-based ACL, IPv6 access list, URPF, and all that thing. Whatever additional stuff are there, we will cover that. So approximately 85 to 90 in total classes. Approximately 85 to 90 classes will be required for our content. So it's by no way it's a boot camp. By the way, it's approximately 90 classes. And if I since our classes are going to be like 2 hours per day, 180 hours. If I say that. Let's say we have the classes for like 1 hour 45 minutes. So maybe like 160 to 170 hours. We will have to spend anyway, like in pure route, which will be beneficial for your production environment as well as the lab environment. And this is specifically routing only. By the way, this is only routing. This is nothing else. This is just the routing stuff. If you talk about like the whole CCI, we have like other things as well. This is only routing. By the way, this is pure routing.
Sir, one
Yes,
question.
yes. Hmm.
So, understanding this concept, we need to do labbing. So, do we have any lab? I mean, a lab book or something, so we can practice it in our
Yeah,
own.
yes. So lab we will talk about in a moment. We'll talk about like how we are going to deliver the lab. But this is the content that we have to focus on, that we will focus on throughout our routing curriculum. Like this is the content that we will focus on from the routing content point of view, and labs I will talk about. I will talk about just in a moment.
Second question is like, can we get access to this sheet? So we have the track for.
This will be built on like for every course. So like this is a general idea, like for example when we have our classes based on how many questions you guys put up, it's not like in day 5 we will cover static routing. Maybe in day 5 we are talking about like routing. Still we are still talking about the routing protocol. So this
Mhm.
index gets created on per course basis. So in your course, like there will be a day-wise planner that you can look up, like on regular basis to keep a track, like to get an idea, like what topic we have covered today, what topic we have covered today. So that will be built on per class basis, per per batch basis. You can say this is just a general. This is just to give you like a general idea that this much stuff is covered. Will take like approximately 85 to 90 classes, up down, like some more, some less, based on like how much. How interactive the session is going to be. So this index might vary, from day wise. The index might vary. So it will get updated like on per day basis. I will say in your course itself. So what I was saying, that this is specifically routing. If you talk about like other stuff such as like switching and all. So this is specifically like routing. And if you talk about like other stuff such as like SD-WAN. So switching, for example. So switching takes approximately like 20 to 20, 22 to 24 days, 24 classes. Switching takes approximately like 22 to 24 classes. A few topics are not there, such as VTP is no longer there in our content. Such as GLBP is no longer there in our content. So, so it takes approximately 22 to 24 classes to complete the switching section. Then it takes approximately like 24, 25 classes for the SD-WAN section. It takes approximately same 24 to 25 classes for the SDA section. So the whole CCIE content is quite vast, I would say. Whole CCIE content is going to take like a lot of time. But from the routing curriculum, from the routing is going to be the biggest topic, I will say. Like routing is going to take like more and more time, and alongside with that, like the other topics such as switching, such as like SD-WAN, will not take that much time, but still like 22 to 24 classes will take like in all of them, like approximately 22 24 classes in switching, approximately 22 24 classes in SD-WAN, same in SDA. Consider 25 25 25, at least 75 more classes for the rest of the stuff. So if you talk about like the entire routing and switching, entire CCI enterprise infrastructure, it is like quite big training, quite time consuming training actually. So in order to reduce the time, what you can do, however, you can, for example, like switching. If you can find some switching batch in the weekend, you can take that. Or if you can find some SD-WAN or SDA batch in the weekend, you can take that, because there is no direct relation of the SD-WAN. Like not that much things you had to know from the routing perspective when we had to talk about SD-WAN. Not a lot of things you have to know about the switching when we talk about the SDA. So you can try to, if you want to complete these things like fast, then you can plan to take a few of these batches in parallel. Like you can take like routing and switching, or maybe switching and SD-WAN SDA in parallel if you can manage the time. Otherwise, like it will take approximately like 90 plus like 75 classes, approximately like 160 classes in total for our enterprise infrastructure content. So it's a quite big training, approximately 300 hours, approximately 300 hours training is there, like for 300, more than 300 hours, I would say, for the entire like enterprise infrastructure. So again, this is the stuff that we'll focus on. This is the stuff that we'll focus on. And throughout the content, like throughout this discussion, we will be in fact using several labs. Those labs will be given to you. And you will be required to practice on those labs as per the time that you get. So, for example, like these are some labs that we have built for our routing. So static routing, EIGRP, OSPF, BGP, for IPv4, IPv6 routing, VRF, PBR. So different labs are there. For example, static routing. This is a very basic static routing lab where we'll talk about the basic static routing, including NAT, PAT, reliable static route, floating static route, and all that thing in this basic topology. Then we'll move on to the other topologies, such as, for example, EIGRP. This is going to be like EIGRP topology, basic EIGRP topology, where we'll practice all the EIGRP relevant stuff. Then we'll talk about like OSPF. We'll talk about like OSPF here. Here is the OSPF topology that we will be working on. We have a few areas, some partner sites, redistribution, LSAs, and all that thing. This is the EIGR. This is the OSPF topology that we will be working on. And same goes for others as well. Same goes for like others as well. Same, we have like border gateway protocol, some BGP topologies actually. For example, some BGP topologies are there actually. Yes. So I will say per technology basis, there is going to be like labs. So for example, when we will be talking about the static routing, I will be using this lab. I will show you all these things in this lab, and it will be your responsibility. It will be your responsibility to repeat everything that I do in the classes, following the videos, following the discussion that we will be having in the class. No troubleshooting, nothing. Your objective is to learn the technology. Your objective is to learn about the static routing. Your objective is to learn all the relevant stuff from the static routing point of view. We will discuss that in this topology, and you'll have to practice exactly the same, exactly what I do in the class. You'll have to repeat it. Maybe what you can do on one monitor, you can open the video, understand what I'm doing, and just repeat it on the lab, on your own lab. Repeat it on your own lab, do the packet capture, see how the packets are flowing and all that thing. Basically, whatever I do, you just have to repeat. Objective is to not complete any task, actually. There's no task solution here. I'm not going to use any PDF. In fact, there is no PDF like that. I'm not going to use like any PDF that, okay, we have to configure the static routing on here to go there. So this is, I'm not going to use like any predefined PDF. I'm not going to use like any document to complete the lab. We will talk about the technology. It's not going to be a task to solution approach. It is not going to be a task solution approach. It is going to be like a complete discussion about the topology, about the technology. So your objective, first thing first, your objective is going to be to repeat everything as exactly the same as what I do. Repeat exactly the same as what I have done in your home lab, and try to understand, try to build the concept, try to understand like what was the objective of the lab, what was the objective of that particular lab, what thing we needed to learn. Okay, we needed to learn like static routing with next hop, static routing with exit interface. What is the difference between the two? What are the challenges we will face? Because if you want to configure the static routing, it will take approximately like 30 minutes to complete all the things. But that's not our objective. Our objective is not to complete this static routing in this topology, but to learn the technology. So there is no PDF. There is no such PDF where we have mentioned any task and we'll have to do the solution. No, there's nothing like that. Nothing for the EIGRP, nothing for the OSPF, nothing for the BGP, nothing. All you have to do is to just repeat what I do in OSPF classes as it is, following the video, following the discussion that we are going to have in the. So if I'm talking about the LSAs, I can configure OSPF in this topology. You can configure OSPF in this topology like in 30 minutes. And the end-to-end reachability will be there. You will be able to ping like from everywhere to everywhere, the internet and all, and this will be done. But that is not the objective. The objective is to know, when you configure the OSPF command, what packet is generated, what packet is sent to the devices, how the LSA looks like inside the packet, inside the LSA, what information inside that OSPF update packet, what information is there. So you will do the packet capture and all that exactly same as I do. So in short, not following any task solution approach, you'll have to repeat exactly what I do in the classes. So when you are sitting in the classes, watch carefully what we are talking about, listen carefully, watch carefully. If you have questions, put those questions, basically ask those questions. Get your technological understanding clear and repeat after the class. You will have the recordings with you. You can just watch the recording one time and then do the lab, or maybe you can watch the recording and do the lab side by side. Basically, try to understand the technology rather than completing the configuration in the topology. That's the objective. So there is no such PDF, there is no such task solution or any kind of like document that will be available for.
So are we going to be using Wireshark?
Yes, we'll be using Wireshark to do the packet capture, to see how the LSAs look like, to see how the IGRP hello look like, what parameters it contains. That's why it's going to take long. That is why it is going to take quite some long time. So your objective is going to be the same. Open the Wireshark packet capture and see what is there in the content. I'm not saying that we have to memorize all that, but at least have the idea that, okay, in the OSTrip hello packet, these are the flags, these are the bits that are there. So if the OSTrip neighborship is not coming up, these could be the possible reason. Why? Because these are the parameters carried in the hello packet. So this goes on and on, this goes on and on and on for all the labs, VPN and all that, every lab. For all the lab, this goes on and on. Same exact approach you will take. Same exact approach you will take for all the labs. Basically, again, repeating the same thing. Understand the technology rather than doing the configuration in the topology. Understand what we are trying to do, the packet capture. If you are able to work on these small topologies, you will eventually be able to work on the large topology based on the requirement. So first clear your technical understanding. The objective of this routing class, switching class, SD-WAN class, SDA class is to clear your technical understanding. So that we will do throughout these labs. So for this training to get completed properly, efficiently, you have to have some understanding of the technology. For example, we will not talk about what is IP address. We will not talk about what is subnet mask. We will not talk about what is subnetting. We will not talk about what is OSI model, TCP/IP model, and all. It's done. For example, in static routing, at least you have to know what is static routing. What is the syntax for the EIGRP? What is AS number? What is this like process ID in OSPF? What is router ID? Some basic stuff you have to know. It is advised that if you have gone through at least up to the CCNP level of training, it will be easy for you to put new questions while we are discussing about the topics. So we will do packet capture and all that thing. So you will be able to put more and more new questions to get the technological understanding clear. So it's not for fresher. That's what I'm trying to say. This course is not for a complete fresher. You have to have some understanding of the technology before you begin. So if you want to refresh, you can watch some videos, you can go to some documents online. For example, I say that tomorrow we'll start EIGRP. So I'm not expecting you to know like whole EIGRP, but I do expect you to know that what is EIGRP? It is an integer gateway protocol. This is the AD value. This is the AS number. This is the router ID that we use. Some basic stuff at least you have to. It's not like I'm going to ask you. I will cover those things. But at least these basic level stuff, at least you have to, at least you know. So some technical understanding of the topics you have to have. About like MPLS, I don't expect you to know anything. About like multicast, I don't expect you to know anything. About like some VPN technology, I don't expect you to know anything. Quality of service, nothing. But when you talk about these general routing stuff like EIGRP, OSP, BGP, at least some understanding we have, at least some.
So we're not covering static routing?
No, we will cover.
Okay.
We will cover, but we will definitely cover. We will talk about static routing in as much detail as we have to. But at least you have to know what is static routing, where we use it, and it must not be like you have heard you are hearing this static routing for the first time. It must not be like that. You have to have some understanding of the things, of the protocols, so that we can talk about it in more and more detail. The objective is to cover the things in as much detail as it is used in the production environment, for example. Any question, anything, any point, any question.
One question, sir. So as we know that routing syllabus is tough and hard as compared to the other technology.
No. I said it will take more time. No, it's from the hardship point of view, like SD-WAN is going to be, SDA is going to be much more comparatively much more hard as the routing. Routing is very straightforward. It will take more time, just because we have many topics to discuss.
Okay. So what you suggest? Can we go for two classes at the same time or focus on one class?
Now, if you can, like, if you, for example, like, if you can manage the time and if you're able to understand the things that we are talking about in the content, then you can definitely go for like one or more than one training at the same time. It's completely on the candidate based on like how much they can practice on regular basis, how much time they are getting on regular basis. So because you have to also, of course, like we are working somewhere, so you also have to manage the work and other things as well. So if you're able to get some time, you can definitely like do like courses in that. Such as, for example, at least switching you can do. At least switching is very straightforward, very easy. I would say switching you can do. SD-WAN requires like more lab. SD-WAN requires like more and more lab actually. So if you're trying to do SD-WAN along with the routing, might be a little bit difficult. In SDA, you will not even have any labs, by the way. So that you can work on, that you can practice on. You will mostly use the D cloud and that stuff for the lab purpose. So the you can do SDA maybe side by side, but you'll have to manage the time accordingly. If you're able to find some time to practice all the stuff that you are taking, then definitely you can do like more than one at the same time.
Yes.
At least some in weekdays, some in weekends. So I generally recommend that if you have some deadline, that no, you have to complete all the things by this time, and you have to take the exam, by within this time period. Then what you can do, then you can do like more than one technology, at the same time. But if you have sufficient amount of time, like you do not actually want to rush the things actually. So I would recommend you do like one by one. From the content point of view, as the WAN is going to be a little bit hard. From the labs point of view, hard basically means like the stuff that you might not have heard before working on SD-WAN technology and all that. SD is going to be similar. SD is going to be quite similar as well. If you're not working on the SDA technology, there are going to be a few terms that is completely new to you. So a little bit, comparatively, a little bit hard is going to be. But other things like routing, switching, it's going to be pretty straightforward. Again, it will be like your responsibility to make this class as interactive as you can. Like ask as many questions as you can. There is nothing like should I ask this question? Should I not ask this question? There's nothing like that. You can ask the question anytime you want. Again, if something that you have to know already, I will frankly tell you that okay, this thing you should know, this thing you should know, this thing you should know. For example, if you're asking me like what does /30 means, that I will say that you have to have the understanding of the subnetting. So practice subnetting, I will say you that. So these things, considering these things in the mind, we are going to complete our routing content first. We'll start our routing content and we will complete our routing content first. You just search CCIE EI lab exam equipment list and you click on the first link, version 1.1. And so when you have to work on the SD-WAN, it is 8000V with iOS XE 17.9, iOS V, router 15.8, switches 15.2, SD-WAN 20.9, and DNS Center 20.2.3. This is and then from the physical equipment point of view, since SDA you can't like simulate, so 9300 series switches with iOS XE, software release 17.9, Linux IS 3.1 used in the SDA, and Linux environment from where you are going to the programming stuff for the programming, some Linux based in. So this is the equipment list for the enterprise infrastructure. So in the exam, 20.9, 50, whatever things we have in our content, whatever things they have asked in the exam so far, all those things we can practice in our home environment, except for the DNS Center. A DNS Center you can't practice in your home environment. It's not virtualized that good as of now. So you can practice it in the cloud. So everything I would say like everything can be practiced either in home environment or Cisco D Cloud in a simulated environment. We can practice all this.
Okay. So, do we get the access to the T cloud as individual candidate, or we need to log in
D
using?
Cloud, like for individual candidate, every candidate logs in with their own Cisco account. So it's like there are several demos that you can explore, and then you can do the practice of the DNS Enter, Catalyst Enter, basically. So we already have gone through all the what things we are going to cover, the topics and all the expectations. Although we have already covered that, although there is no like such prerequisite for this CCIE Enterprise Infrastructure, but you should be at least familiar with the basic concepts of the. You should be familiar with the basic concepts of the technology, such as like EI, GRP, OSPF, some basic understanding of the topologies you have to have, some basic understanding of the protocols you have to have. It is recommended to have like Encore and RSTP training just in case, so that we can discuss the topics in as detail as we can in the enterprise. But throughout the content, it will be assumed that you have some level of understanding, some basic understanding about the topics like EIGRP, like OSPF, some basic level stuff. Already, this discussion is already done. This thing we already have covered in the last class. Nothing like special here. So we'll be starting our technical content today, starting with like the fundamentals of the routing, like what is routing, what is the routing fundamental. Now, what exactly is in fact routing? Let's discuss about it. Let's talk about that. So when it comes to routing, what exactly is routing? Routing is a process. Routing is basically a process of forwarding the packets based on the layer 3 address. Layer 3 address, that is the IP address. Forwarding of the packets based on the layer 3 address or IP address is what we refer to as the routing, also known as layer 3 forwarding. So when any device that can receive the packet, take a look at the destination IP of that packet, and it is able to forward that packet from one interface to the interface, like from this interface to this interface. If that forwarding can be done based on the destination IP, that process is what we refer to as the routing. And whatever devices are able to do that, whatever devices are capable of doing it, these are referred to as the layer 3 devices, because IP layer 3 address. So whatever devices can forward the packet based on the layer 3 address, they are known as the layer 3 devices. An example of the layer 3 device would be a router, a layer 3 switch. Basically, any device that can forward the packet. Basically, any device that can actually forward the packet, based on the destination IP is going to come under that routing capable device. And one of the common example of a routing capable device would be a router, a layer 3 switch, for example. So we can have like some routers in our topology. We can have some switches that are capable of forwarding the packets based on the destination IP in the topology. So router, layer 3 switches, these are some common example. These are in fact some common example of layer 3 devices. So when the packet arrives on a layer 3 device, such as a router, when a packet arrives on that router is going to perform decapsulation. Router will decapsulate. Router is going to open. Router is going to decapsulate that packet. It is going to take a look at the destination IP of the packet. And based on the destination IP, the router has to decide whether it has to forward the packet out of this interface, or if it has to forward the packet out of this. Out of which interface? Out of this interface, or this interface, or maybe this interface. Out of which interface this device has to forward the packet? Out of which interface the packet must be forwarded? That this router first will find out. And once it finds out, once this router finds out that in order to go to that destination, I have to forward the packet out of the interface 0 by 1, let's say, then it will in fact forward the packet out of that particular interface. Basically, these layer 3 devices, these routing capable devices must know, the exit interface. They must know the outgoing interface. They must know the exit interface from where they can actually forward the packet. If these layer 3 devices, if on these layer 3 devices we want to perform the routing, if I want that these layer 3 devices should be able to route the packet respectively, then they must know, like, this is the exit interface from where we have to forward the packet in order to reach to this destination, or this interface, or this interface, or that interface, basically. So they must know about the particular exit interface from where they have to forward the. So they maintain a table. All these devices, they maintain a table, and in that table they keep this information that if I want to go to this destination 1, 2, 3, 4, I have to forward the packet out of the interface FA0x0. If I want to go to 4321, then I have to forward the packet out of the interface 0x1, then this, then that, then this, then that. So these devices, these routing capable devices such as a router, these routing capable devices just such as a layer 3 switch, these routing capable devices, they basically maintain a table. In that table, basically they have this information that if I want to forward the packet out of if I want to forward the packet to this destination, here is the exit interface that we have to actually, and that table, by the way, that table is known as a routing table. A routing table is something that these devices maintain. These devices are going to maintain a table, these L3 devices, such as routers, such as these L3 switches. They are going to maintain a table. That table is referred to as the routing table. And in that table, they keep this information. In that table, they keep this information that if I have to go to this destination, then I must forward the packet out of that particular interface. This table is called routing table. Layer 3 devices maintain a table called the routing table. In that table, they maintain the information about the destination network, that if I have to go to this destination network, then I have to forward the packet out of the interface 0x0. If I have to go to this exit, if I have to go to this destination network, then I have to forward the packet out of the interface 0x1. They maintain that information in a tabular format, in a table format, which is what they refer to as the routing table. And this routing table basically consists of the destinations, and this routing table consists of destinations and its respective, its respective like exit interface to reach to that particular destination, and the exit interface to reach to that destination information is maintained in a table called the routing table, which is consulted, which is looked up, which is consulted, which is checked by these routing capable devices when they have to decide out of which interface they have to forward the packet. Basically, layer 3 devices, basically a router, a switch, any device that can do the packet forwarding based on the destination IP will look up a table called the routing table to decide out of which interface we have to forward the packet, 0x0, 0x1, 1x0, whatever. And that table, by the way, that table that table we can check. We can check that table by command show IP route, of course. We can use the command show IP route to check that table. We can use the command like show IP route to check that table. In that table, you can see in the show IP route, you can see that we have some routes that if you want to go 10.04.0/24, then you have to exit out of the interface 0x1. If you want to go there, then there. If you want to go there, then there. If you want to go there, then there. Basically, in this table, as you can see, there is information about a particular network and its respective exit interface. And how they have learned about it, how they know who told them, who told these devices that if you want to go to that destination, you can exit out of this interface. Who told the devices about it? That information is also there. Codes, C stands for like directly connected, L stands for locally configured. Whatever IP we have configured on that particular interface will be displayed in the routing table as well. Then EX, D stands for EIGRP, S stands for static, O stands for OSPF. Basically, all that information about the device, all that information about the device, and all that information about the device and device like subnet. How can I reach to that particular device? How can I reach to a particular subnet? That information is maintained in this tabular format, in this table format. That the routers, that the L3 switches are going to look up. They will look up this table. They will look up this routing table, and then they will do the forwarding based on this information. So in the routing table, we have this thing called the network and subnet. In the routing table, we have a network and a subnet mask. We have a network and mask. A router, here is a router, for example, it might be connected to like multiple hosts here. 192.168, 10.1, 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8. But the router is not going to maintain the individual IP information. That if I have to go to 10.1, then where should I go? 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8. The router will not maintain. Router is not going to maintain the information. The router is not going to maintain the information about individual IPs. that if I have to go to these IPs, then I have to go to out of the interface 0 by 0, for example. Router is not going to maintain the information about individual IPs. Instead, this router is going to maintain a range. In the routing table, the router is not going to maintain the information about these individual IPs. Instead, the router is going to maintain a range. Router is going to maintain a range that if you want to go to this range, if you want to go to this 190 to 168.10, if you want to go to 190 to 168.10's network, then you have to exit out of the interface 0 by 0, then 20.0, then 0 by 1, then 30.0, then here or there. So the router is going to maintain a range that if you wanted to go to that destination, you can exit out of this interface or you can exit out of that interface. That information will in fact be maintained in a range format in the routing table, not as the individual IPs, by the way. The router is not going to maintain the individual IP information. Instead, the router is going to maintain a range. The router is going to maintain instead a range. So that range is represented by this network ID. That range, by the way, is represented by this network ID, and the range is represented by this network ID and the subnet mask. This range, by the way, is represented by the network ID and subnet mask. This range is represented by the network ID and the subnet mask. Remember that network ID, a subnet mask will always give you a range. For example, this right here, it is like if you want to go to 10.0.4.0 to 10.0.4.255. If you want to go to like any IP from this range, you can exit out of the interface 0 by 1. These destinations are reachable. Out of the interface 0 by maintaining a range rather than individual IPs information. By maintaining a range rather than maintaining individual IP information, of course, like the size of the routing table will not increase a lot. The size of the routing table is in fact not going to increase a lot. Size of the routing table is not going to increase like a lot. Like instead of maintaining the individual IPs information, we are just maintaining a route. So the size of the routing table is not going to increase like a lot. And all the destinations will still be reachable. All the destinations will still be reachable while not maintaining individual IP information in the routing table, which is of course like, quite a good advantage. Routers, they don't need to maintain the individual IPs information in the routing table when they can just simply maintain a range that if you want to go to this range, exit out of this interface or that. And that's what actually happens. This is what actually, so this network ID and mask that you see, it represents the range. It represents the range of the IP addresses that is reachable. Then how I know about that range? Who told me about it? Like, how do I know about that range? Is it directly connected? Is it like statically configured? Are we learning it about are we learning about that destination IPs using some EI-gRP OSPF protocol? How exactly? The code represents like how the router, that L3 device has learned, how that L3 device has learned about the particular subnet. How that L3 device has learned about the particular subnet. Code, that's code. What is the trustworthiness of that information? If you learn about that information via some routing protocol such as EI-gRP or such as OSPF, what is the trustworthiness? What is the trustworthiness of this information? That trustworthiness of the information is represented by a number called AD, administrative distance. Reliability, trustworthiness, like reliability, how reliable this information actually is. How reliable this information actually is. You are telling me about that network. how reliable that information actually is. That I would say that reliability concept, that reliability thing is in fact handled, maintained by this thing called AD. AD stands for administrative distance. AD stands for administrative distance. AD, administrative distance, defines the AD or administrative distance basically defines like the trustworthiness of routing information source. Trustworthiness of routing information source is in fact defined by AD, by administrative distance. And metric, right alongside it, we have this thing called metric. Metric is like a metric is basically like a unit of measurement used by these routing protocols to decide the best path. How these routing protocols basically decide the best path. How these routing protocols they decide the best path. It is represented by this thing called AD. AD stands for administrative distance. The best path selection criteria. How these for example routing protocols decide the best path. That is like metric. And metric is basically a number. Metric is just a number that represents a bit of measurement that is used by the routing protocol to decide the best path. These routing protocols have decided that this is my best path, that is my best path based on this concept of metric. So for example, like in static routing, we don't have any metric. Directly connected route, they don't have any metric. EIGRP works on composite metric. OSP works on cost. BGP have some attributes, by the way. So the best path is decided. The best path is decided based on this concept called best path is decided based on this concept called metric. Metric is more like a unit based on which these routing protocols they decide the best path. Okay, so we have AD and then we have metric. Then we have the exit interface, by the way. We also have the exit interface. Exit interface basically means exit interface basically means like what is the interface from where we have to exit in order to go to that destination. If I want to go to that destination, then out of what interface I must exit. Out of what interface I must exit in order to go to that destination. That is, by the way, exit interface. That is, in fact, the exit interface. Also, there is a thing called the next hop IP address. There is a thing called next hop IP. This next hop IP address, by the way, this next hop IP address, what exactly do we mean by, this next hop IP address, by the way? So assuming that this is the source and this is the destination, I want to go from here to there. And in between, there are like multiple routers connected. So from this source point of view, if I have to go to this destination, I am not directly connected with that destination. Next hop basically means next stop. That if you want to go to a destination, what is going to be your next stop? If these two machines were directly connected, then for this PC, this destination is the next hop. For this PC, this destination is in fact the next hop. If, for example, these PCs were directly connected, the destination is going to act as the next hop. Destination is the next hop. Right? From here, from this source to this destination, if I want to go, since I'm not directly connected, I will forward all the traffic to my gateway. So from this PC point of view, this IP, this gateway is going to act as my next hop. I will send the packet towards the router number 1. R1 will receive it. And when the router has to forward the packet towards this destination, the router will take a look at its routing table and find out that in order to go to that destination, I must forward the packet to router number 2. So from this router point of view, this router number 2 is in fact the next hop. Then the packet will reach to router number 2. From the router number 2, this router number 3 is going to act as the next hop. From this router number 3 point of view, from this like router number 3 point of view, from, for example, this router number 3 point of view, from this router number 3 in fact point of view, the next hop from this router 3 perspective, from this router 3 point of view, the next hop is going to be router number 4. Then from router 4, it's router 5, then router 6, then router 7, and then eventually the packet will reach. Then eventually the packet will reach to the destination. So next hop basically means next stop. Next hop basically means the next stop. That if I want to go to that destination, what is my next stop? Am I directly connected? In that case, the destination is the next hop. But if you are not directly connected, by the way, if you are not directly connected, in that case, the next router, the next router is the next hop, the next router is the next hop, the next router is the next hop, and so on and on and on until you reach to that destination. So that next hop IP, what is the IP address of this interface? What is the IP address of this interface? What is the IP address of this interface? That IP will be the next hop from the router 1, router 2, router 3, router 4 point of. So that next hop information is also maintained. That next hop information is also maintained in the routing table. In the routing table, we will have that next hop information maintained as. We will have that next hop information. We will in fact have that next hop information maintained as well in the routing table. So routing table includes the network ID subnet mask, which eventually gives you the range. Code represents like how do I know about that particular subnet. Then AD and metric. AD stands for the coordinates of the routing information source. Metric is basically like how the particular protocol has calculated the best path. The best path is measured in terms of like metric, like hop count, composite metric and all. Next hop IP address, the exit interface. Exit interface, like if I want to go to that destination, out of which interface should I exit? So this interface, in order to go to that destination, this interface will be the exit interface. This IP will be the next hop IP. This interface will be the exit interface. This IP will be the next hop IP. Exit interface, next hop, exit interface, next hop, exit interface, next hop. That information will in fact be present. That information will be present in the routing. Also, default route, that if you don't exactly know, if you do not exactly know how to go to a certain destination, then you can reach to the destination. You can reach to the destination using this thing called the default. Default route is gateway of last resort. Default route is gateway of last resort. Default route is gateway of last resort. That if you don't have the exact route to reach to a destination, then you don't need to drop the packet, because if the router does not know how to reach to a destination, the device will of course drop the packet. If I don't know how to go there, then I will not be able to go there, of course. If I don't know how to go there, then I will not be able to go there, by the way. So in that particular case, basically, the router is in fact, I want that the router must not drop. I want that the router must not drop the packet if it doesn't know how to go to a certain destination. Instead, I want that router to forward the packet. Instead, I want the router to basically forward the packet to the. I want the router to forward the packet to the particular next hop. I want the router to forward the packet to a particular next hop. So that is more like going to be the next hop. The next hop is basically in fact basically how to forward next hop is the next router, next device where the packet will be forwarded. Next hop is the next device where the packet will be forwarded. And this default route means that if you don't have the exact route to go to the destination, if you do not have like the exact route to go to the destination, then you do one thing. Then you forward the packet to the particular. You forward the packet to the particular next hop. You forward the packet to the particular next hop. Don't drop it. Do not drop it. Instead, forward the packet to the particular next hop. Do not drop it. Don't drop that. So routing table can also contain this thing called the default route. Routing table can also contain this thing called the default. So this is the.
So sir, next hop always has to be the next device.
Yes. Next hop will. Next hop means like next stop. So technically speaking, yes, the next hop will always be the next device where you have to forward the packet. Like if I want to go from here to here, this is my next hop. Packet will reach there. Then from here to go there, this is my next hop. Hop by hop, packets are going to be forwarded. So the immediate next device is going to act as the next hop for you. That information that is basically the info. In some cases, this next hop information, by the way, in some cases, this next hop information is automatically there. In some cases, this next hop information is in fact automatically there. But in some other cases, you will have to provide that next hop information all by yourself. But in some cases, that next hop information will automatically be there. So here, for example, in our case, maybe we have configured a static route. And while configuring the static route, we have given the next hop ourselves. Or like when the route is learned via protocols such as EI GRP, then the next hop information was derived automatically. Maybe so this next hop information, information is going to be there. This information is about the next device, the next intermediate device, the next device where we have to forward the packet. Actually, that next device information is in fact what we are going to refer to as the next. So basically, this is how like I will say this is how the things are going to be. This is how these things are. This is how the information is in fact maintained. This is how the information is in fact maintained in the routing table, and packet forwarding is done based on the entries present in the routing. So what I'm going to do now, I am now going to in fact build a simple topology. I will build a simple topology, and that topology we will configure the IP address, and we will learn about, like, we will revise some basic concepts regarding our encapsulation, decapsulation. We'll talk about the packet flow. We'll talk about like how the packet flows from one point to other point when we do the ping, when we do the trace, when we, let's say, for example, when we send some TCP packets, some UDP packets, and how the packet forwarding actually happens. We will now first learn about that. We'll talk about like how the packet forwarding happens, and for that I'm going to basically build a simple topology in ENG. So nothing like new here. I'm going to create a new folder, the new lab, add a new folder that is CCIE EI, and here I'm going to create a new lab. So basics. The basic, nothing here, just a blank page here, nothing that we have configured here. And here I'm going to do I'm going to build the same topology as in this diagram here. So I will have like 2 routers, 2 switches, and 2 machines. Okay. So first of all, I will have 2 routers. So I will right click node, and I'm going to use some IUL based devices. I'm going to use this router, this L3 image, this L3 Advanced Enterprise K9, this L3 image I'm going to use. And I'm going to take 2 routers. This is the image that we are using. This L3 Advanced Enterprise K9 157 May 2018. This is a very stable image where we can practice like almost everything that is there in our curriculum. So this is the image that I'm going to use, and I'm going to use like two nodes basically. And okay, so this is router 1, and this is going to be router 2. And by the way, like in this EVNG, in this IUL based devices, we do not have any serial interface. So if you want to add the serial interface, then you will have to right click, edit, and you will have to add a serial interface just in case if you want to have it. I'm going to add a serial interface here. Here I'm going to edit and add a serial interface so that I can also use that. You will not be able to do the packet capture on the serial, by the way. So I generally don't use it, but anyway. Then I'm going to add 2 switches here. So nodes, again, IUL based devices I'm taking. And this time it's going to be L2. This L2. This is L2 image. This is switch image. I'm going to call it like as W. Switch. I'm going to add 2 nodes. And the symbol I'm going to change to switch. The symbol I'm going to change to switch. Simple switch. Right. So one here. And then I'm going to use like, as per the diagram, I had to take like two PCs. What I'm going to do, since we'll be practicing about like telnet, SSH, these things, what I'm going to do here, I'm going to instead, I'm going to use, ultimately, I'm going to use these routers actually as the, I'm going to use these routers as the as the end devices. So I'm going to add here 2 more routers. So node, and I'm going to add like IOL, 2 more routers. I'm going to add 2 more routers. I'm going to add, and I'm going to actually change the symbol. So on one type, it is going to be a desktop, a desktop basically. On one side, it's going to be a desktop image, right? A desktop image, and on one side, it's going to be a desktop, and on other side, it's more like going to be some sort of like server or so, whatever. So I'm going to change the symbol, edit, and I'm going to change the symbol to some server. It's not actually server, it's just a normal, server. This is going to be, and this is going to be PC. This is going to be switch 1, and this is going to be switch 2. And the connection, connectivity, the connection that we have to make, FA 0 by 0 goes on the switch. Okay. So here, Ethernet 0 by 0 goes onto the switch. There is no FA, there is no fast Ethernet. So these are going to have like Ethernet. So Ethernet 0 by 0 goes on the switch here. The Ethernet 0 by 0 goes on the switch there. And in between, serial interface is there. So I'm going to add the serial link here, serial 1 by 1, 1 by 1. And here, then I can connect whatever. Right. So this is the topology. This is the basic topology that we have, and this is the topology that we'll be working on. And first of all, here we'll configure the IP and all that thing. So as mentioned, the IP address is going to be 192.168.1, then 2, then 3. Okay. So it's going to be text 192.168.1.0/24 and this is going to be 1, this is going to be 2, and this is going to be 3. So 1.1, 1.2, this is 192.168 1.1, 1.2, this is 3.1, 3.2, this is 2.1, 2.2. That's the IPs that we have to configure. So I'm going to power on these devices.
I think the serial interface should be 2.0, right? But you said 1.0 as well.
Oh, sorry.
Between the 2 routers, yeah.
Here, that has to be 2.0. They are also changing, by the way, the MAC address. I will also change the MAC address so that we can understand this process properly. So although MAC address is there on every interface, so I don't technically have to do anything about it, but to understand the process properly, I will in fact do the change. So as per the topology, let's first configure the IP address on the PC. This is the PC. Here, it's a router, by the way. It is not actually any PC also. It is just a router. And yes, no, again, I will say no. And the very first thing that I will do here is that I'm going to disable here the routing capabilities. Enable, configure terminal. This is going to be host name PC1 and no IP routing. So I have just disabled the routing capability to more like make it act as a simple device, like not a router also. So I just configure the command no IP routing. And I will configure an IP address interface 80 by 0. First of all, IP address, that is 192.168.1.2 as mentioned in that diagram. And by the way, this is also /30. This is on the side, it is 24 in the diagram, and in between it is 30. So 24. And although I don't have to, but MAC address. I will also configure the MAC address so that we can understand the process properly. So MAC address AA, BB, CC00, and this is 1000. You can configure whatever MAC address. I'm configuring this MAC address AA, BB, CC00, 1000 so that we can understand the process of ARP, ping, trace properly. As soon as I do no shut. As soon as I configure no shut command here, what will happen in the background? As soon as I configure the no shut command here, what will happen? The very first thing that this machine is going to do, it will try to find out whether this IP address that I'm trying to configure is unique or not. Basically, the machine will try to check whether this IP address that I'm trying to configure is unique or the uniqueness will be checked. It will be checked whether this IP address is unique or not. Because if this IP address exists, somewhere else, if this IP address exists like somewhere else, then of course, like I'm not going to, I can't use the same IP address. So this machine will try to, this machine will try to find out whether this IP address is unique or not. In order to do that, in order to find whether this IP address is unique or not, what this machine is going to do? This machine is going to generate and send an ARP. This machine is going to generate and send an ARP message, an ARP message. And that ARP message, the objective of the ARP, the objective of the ARP, the objective of the ARP is not actually to resolve any. The objective of this ARP is actually not to resolve like any MAC address from the IP address. No, it's not like that. It is not responsible to do that. This ARP is basically responsible to resolve. This ARP is basically responsible to notify everyone. This ARP is there to notify everyone that here is my IP, here is my MAC address. If anyone else has the same IP or MAC address, let me know. Let me know so that I can notify the administrator so that the admin starts using some other IP address. I still did not press enter. As soon as I press enter, that will happen. But before I do that, I will do the Wireshark capture. So I will just go here and right click and capture, and I will capture that interface 0 by 0 so that whatever packets are sent, we are able to see those packets. Now we don't really care about these STP or anything. We don't really care about these. These messages are being sent via that switch, so we don't really care about these packets. All I have to do is to just press enter, and as soon as you do that, before this IP gets configured on the interface, before this IP address gets configured on the interface, enter. You can confirm, you can check that the machine will first send some ARP. The machine first has sent some ARP. It has sent some ARP, address resolution protocol. It has sent some ARP messages. That ARP, it is a special type of ARP. Its responsibility is not to resolve a MAC address from the IP address, but to tell everyone about the IP address that we have configured. Gratuitous ARP. Gratuitous ARP, basically, or GARP in short, it is more like an ARP reply. It is more like an ARP reply that is sent without receiving the ARP request first. I did not receive any ARP request, but I am just sending an ARP reply. I have not received any ARP request, but without receiving any ARP request, I am sending an ARP reply, which is to inform everyone, which is to basically inform everyone that here is my IP address, gratuitous ARP, basically, or GARP. If you open that ARP message, the hardware type is still Ethernet, the protocol type is still IPv4. This information is exactly the same, and you can see clearly here, it's not an ARP request, by the way, it is eventually an ARP request.
So it doesn't start with the request. It doesn't. Yeah, so this ARP doesn't start with the request.
Yes. This ARP doesn't wait for any request. Okay. So this will be sent as soon as I try to configure any IP address on the interface, whether your laptop, desktop, or like printer, server, whatever devices we have in the network. When we configure some IP address on those devices will first send an ARP. And format of ARP called GARP, gratuitous ARP, which is eventually an ARP reply, responsible to tell everyone that hey, here is my IP address and here is my MAC address. The objective of this ARP is not to resolve any MAC address from the IP address. That's why you can see that in the target IP, target MAC actually is target IP address is my own IP address, and target MAC address is more like a broadcast MAC address. Like it doesn't make any sense. This is my IP, this is my MAC. I am telling everyone about my IP and my MAC. And I don't actually expect anyone to give me any reply, because that would then imply that someone also has the same IP address. So now, so in this ARP reply, this is not a reply of any request. It is in fact it is in fact just a normal ARP. So this ARP reply, this gratuitous ARP was sent. It is broadcasted. Remember that ARP reply is unicasted, na? If you remember that ARP reply is unicasted, ARP request is broadcasted, ARP reply is unicasted. But here, since it is not, it is actually not. It is not a reply that we are sending in the response of any request. You can see that is gratuitous ARP. This GARP is being broadcasted so that everyone in my broadcast domain this broadcast domain comes to know, here is my IP address. If you have the same IP, let me know. And it sent like multiple, it sent like 2 GARP, just in case like if one gets dropped somewhere, it sent like two GARP messages. And fortunately, it did not get any reply of it didn't get like any response in this of these like ARPs. So it is now confirmed that this IP address that I'm trying to configure is unique, and it was able to configure that IP address on the interface successfully, and you can confirm it. Show IP interface brief command. You can confirm that IP address was successfully configured. And if you do the exact same thing, if you go on the router, I am now going to the router, and on that router, I'm going to configure, by the way, yes, no problem. Okay. On that router, I will configure, since I have done the capture on this wire, I don't need to do the capture on this wire because those messages will pass anyway from there. I don't need to do that. So now if I go to the router, hostname R1, and here I try to configure interface 0x0 and MAC IP address 192.168, if I configure the same IP address exactly, and I say like some MAC address like AA, BB, CC, 001001, for example. Now, as soon as I do this no shut here, immediately this machine will repeat the same process. This machine will do the same process. This machine will first try to find whether this IP is unique or not. So in order to detect it, it will again generate a GARP, a gratuitous ARP message, putting its own IP address, MAC address in the source IP, its own IP address in the target IP. Basically, it is informing everyone that here is my IP address and the respective MAC address. So if anyone has the same IP, let me, so that we can detect the IP conflict. And unfortunately, when this GARP message basically is sent, unfortunately, that IP is configured somewhere else also. Meaning to say that if you take a look at this next GARP messages, you see here, when this particular PC, when this router sent that ARP, when the router sent that ARP, that GARP, informing everyone about the IP address and the respective MAC address, unfortunately, that GARP message, when it arrived on the PC1 had the same IP configured on the interface 0x0. So in this broadcast domain, we are actually having 2 machines with the same IP address. And when that happens, this PC is going to send more like a GARP of its own, saying that I have the IP. This IP address is assigned to me. This is my IP, my MAC, my IP, my MAC. And that is the point where this IP duplicacy. This is the duplicate IP was basically detected. The duplicate IP was detected in the network based on that GARP. But it did not stop. That machine from assigning that IP address. It's not like ARP has that much authority that it can prevent the machine from assigning the IP. Of course not. That's not going to happen. So basically, what has happened that in your network you have 2 machines with the same IP address. You got to know about it. By this message, duplicate IP on the console. You got this message. You got to know about it. On your Windows machine, on your Windows laptop, for example, I have seen a duplicate IP conflict. By the way, IP conflict message, on the Windows machine. Basically, we used to see this IP conflict message here. Here, some sort of this Windows has detected an IP conflict, and the computer is using the same IP address. So this kind of thing basically. This kind of message would appear in the machine saying that like same IP is also configured somewhere.
Sir, here we are using a router to simulate the PC, but like in case of real PC, does PC generate GRP also?
Yes,
When we configure the IP address?
So
okay.
Yes, correct. Most of the devices that we have where we can configure an IP address, they will first try to detect whether that IP which you are trying to configure is unique or not by sending that GARP, that gratuitous sharp. And if they will not do anything about it, actually, they will just prompt you, they will just show you a message that the same IP is configured somewhere else as well. It's not like a PC has removed that IP address. No, it's not like that. You can see it's not like that the machine has removed the IP address. No, it's not like that. It is just now in your network, you have two machines with the same IP address.
Yeah, it will still assign the duplicate IP.
Yes.
You would just have issues with.
The problem is that when we have a PC that wants to communicate with 192.168.1.2, when the PC wants to communicate 192.168.1.2, 1.2 is actually the PC. There are very good chances that the packet might go towards the router because same IP address since it's configured on two machines, this IP is configured here as well as here, and as per the rules, we must not have the same IP address on two or more machines in the same broadcast domain. This is my broadcast domain. This is my network. One broadcast domain, one network. This is my broadcast domain. So I must not have duplicate IPs in my broadcast domain. Because if that happens, then the packet might not go towards that machine. The packet might go towards some other machine. So in a simple network, in a simple local area network, if two machines are not able to communicate, do cross-check whether IP duplicacy. Do check if same IP address. Confirm that on the devices you have a unique IP address. Confirm that no two devices have the same IP address.
Is that possible with DHCP?
It is possible. Generally, DHCP explain that as well, but DHCP also detects. Like DHCP also detects whether the IP that I'm trying to configure is unique or not. Actually, good question. That I will show you on the right hand side in a moment. I will show you that same thing in the right hand side. But the DHCP will also first try to find out. The DHCP works on the DORA process. Okay, fine. Discover, offer, request, acknowledgement. Good. Okay. But when the DHCP server receives a DHCP request from a machine that I want an IP address, actually the DHCP server will also, before assigning the IP address to the machine, it will also first must confirm whether the IP that it is trying to configure is unique or not. If that's not unique, it will not assign it. I will explain you the process in a moment. But to fix it, of course, like go on the router and make sure that you connect to the IP.
And how can we check for duplicate IP?
Unfortunately, like on the machines, on the consoles, on the PCs, if you are getting this kind of logs, then it implies that you are having some duplicate IPs. On the laptop desktops, you might get that pop-up, that duplicate IP duplicacy. But unfortunately, apart from that, natively, you will not be able to detect it. Maybe you can try to do the ping and trace to find out whether that IP is reachable or not. And if it's not reachable, then there could be a chance that duplicate IP is there. But unfortunately, unless you use some tools, some monitoring tools or some sort of tools, unfortunately, like if you miss this log, nah, done. So maybe you can export this log using SNMP to an SNMP server. Maybe you can export this log using syslog to a syslog server, so that you get the alerts, you get the logs on the monitoring software, so that you come to know like whether this IP is duplicate, not duplicated. Now, since we asked the question about the DHCP, okay. So let me do one thing. On the right hand side here, on the router number 2, this is the router number 2. On the router number 2, I'm going to configure an IP address. So I will configure the IP address on the interface 050, which is 192.168.3 subnet. And I will configure. So enable, configure terminal, host name R2, interface 050, IP address is going to be 192.168.3.1, 255.255.0, MAC address. I don't have to, but just so that we can understand the process properly, I will just configure something like that. And when I do the no-shut there, by the way, when I do the no-shut there, the same process will happen there as well. Like the same process will in fact eventually happen there as well. So if I do the no-shut there, this machine will also try to find the same exact, all those same exact things. So, all that same thing. You can confirm in the capture, by the way. You can confirm in the capture that Gratitas was sent here as well. No duplicacy found, so all good here. And what I'm going to do, by the way, I will go on this router. I will go on this router. By the way, I believe on the switch, on the switch, I don't have to do anything. Looks okay to me. Leave it. So on this router, I'm going to configure a basic DHCP. I hope you already know the DHCP commands: IP, DHCP, pool, right side, whatever. And network, I'm going to configure 192.168.3.0/24, default gateway 192.168.2.1, DNS server 8888, domain name IP.com, lease 1 day, lease like 1 day, 2 hours, 4 minutes. I can also configure some lease also. So I configured a basic DHCP. Now, if I go on that server, and I just say on this server, if I configure that on this server, if I want to say that I want to get the IP from the DHCP. So enable, configure terminal, host name, server 1, and interface each 0x0, then MAC address AA/BB/C002000 and IP address DHCP. This command is basically on that device to ask the IP address from the DHCP server. IP address DHCP. And then do the no-shut. Now, as soon as I do that, what will happen, this machine will generate a DHCP message called the discover message. DHCP works on the DORA process, discover, offer, request, acknowledgement. So client sends a discover, which is broadcasted, received by the DHCP server. The DHCP server will send an offer. At the moment, I will say it is also broadcasted. Then the DHCP server will send a request that is broadcasted, and then acknowledgement that is broadcasted. So 2 messages are sent by the client and 2 messages are sent by the server. At the moment, just understand that all these are broadcast. Now, when this client sends the DHCP discover packet to router number 2, basically broadcasted, and that broadcasted packet is received by the router number 2. Router number 2 is the DHCP server. R2 is the DHCP server. R2, understand that router 2 will receive that DHCP request here onto this interface. This interface is part of what network? 192.168.3 network. This router will check whether since by the way, this router is running the DHCP services, since that service DHCP command is already running, since this is a DHCP server, the router will now check, do I have a valid pool from where I can configure an IP address, from where I can offer an IP address to the machine. So understand that the DHCP discover packet was received onto this interface. This interface is part of 192.168.3 subnet. So this router will check the pool for 192.168. The router will check the pool for 192.168.3. And since we do have a pool on for 192.168.3, this router will try to offer an IP address. So it will see what IP is available. What IP is available that I can offer this machine. 192.168 3.1? Nah, 3.1 is my own IP. 3.1 I can't. 3.1 is my own IP. In fact, IP DHCP excluded address. Generally, what we do, whatever IP we have configured statically, generally we exclude those IP addresses as well. But anyway, 3.1 is its own IP address, so that will not be offered. So the next available IP, show IP DHCP pool. The next available IP, I believe like it has already leased one IP address to someone. I will find out where. But the next available IP that I will offer is 192.168.3.3, current index. Whatever IP is there in the current index, that is the next IP that I'm going to offer. And by the way, before offering this IP address, this router must first confirm whether this IP is unique or not. It must first confirm whether someone has configured this IP address statically or not. It will first must confirm this IP address, the uniqueness of this particular IP address. So you notice if you go to the server and you do the no shut, let this server ask for the IP address from the DHCP. And once the interface comes up, it will send the DHCP discover, offer, a request, acknowledgement, and you can filter out all the rest of the communication. And you can see if you just filter the DHCP here, you can see that at the very end, you can see discover, offer, request, acknowledgement. You can see that DORA process has completed. You can see that the DORA process basically has completed, and you will get the IP what? You basically got the IP 192.168.3.3. But actually, DORA, discover, offer, request, acknowledgement were not only the 4 messages that were sent. This is the DHCP. This is the DHCP that will use the discover, offer, request, and acknowledgement broadcast. You can see broadcast, 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 all broadcast. You can see all broadcast. It's all broadcast. Discover, offer, request, acknowledgement, all broadcast. Understand that when the client sends the discover packet, understand that, see, right here you see. Where is that? Where is the discover? Here's the discover packet, by the way. The client sent a discover packet. In the discover packet, DHCP, by the way, is an application layer protocol. In that discover packet, the client is reporting its IP address to be blank 0000. Client is reporting its MAC address in that discover packet. Nothing special. Client ID. Client ID is basically the client MAC address. Client is in the discover packet. There is nothing. In the discover packet, basically, I'm trying to discover a DHCP server. That discover packet has the source IP 0000, the destination IP 255.255.255.255, source port number 68 because client, 67 because server. When the discover packet was received by the DHCP server, the DHCP server will check its pool. What IP can I assign? What IP can I assign? Oh, I can assign 3.3. Okay. This is my current index. This is the IP that I'm supposed to offer. Is this IP unique? Here, right here. It generated an ARP request. It is trying to find out if someone has the IP address 192.168.3.3. It is a normal ARP request. It is a normal ARP request which is trying to resolve the MAC address of 3.3. This ARP request is broadcasted, so everyone gets a copy of this ARP request. And if someone has configured that IP 3.3 statically, or if someone has already got that IP via DHCP, they will send the ARP reply, and the DHCP server will come to know that this IP is already configured. But since that did not happen in our case, I sent the ARP request, but no ARP reply. Sent the ARP request, but no ARP reply, which eventually confirms that this IP, no one has this IP. And then in the offer message from the DHCP server broadcast server client, then in the offer message, the machine is going to offer you the IP address 192.168.3.3 along with the other parameters such as subnet mask, such as DNS, such as domain name. It is offering you all the parameters. The renewal time, like you'll have to renew the time. The lease time is 24 hours. 24 hours, 26 hours, 4 minutes, by the way. Renewal time is half of it. Understand that? Renewal time is half of the lease time. So IP address gets renewed in the half time, so that you don't have to, it doesn't happen that if the lease time is 1 day, it does not happen. It does not happen that after 1 day, the IP address will be gone from your machine and a new IP will be requested. That doesn't happen. Because if the lease time is 1 day, 2 hours, 4 minutes, then half time of it, the IP will be renewed for the next 24 hours. So that renewal time, that lease time, the DHCP server information, plenty of information is there in the offer packet. This is the offer packet that includes plenty of parameters. So it will check. The DHCP server will check whether this IP that I'm trying to offer, if it is configured on somewhere or not, by sending a normal ARP request. And if it gets the reply, it can't configure that IP. So it will increase that. It will change that current index from 3.3 to 3.4, and then it will offer that. It will first send an ARP for that IP, and if that is also configured, the next IP ARP, until it finds the IP that is not configured anywhere. That offer. Then the client sends request. Whatever you are offering now, okay, fine. I am requesting you that you assign me that IP address. Yeah, okay, give me the IP. Server says, oh, okay, take this IP. I have assigned you this IP address, this subnet mask, this default gateway, this DNS, this domain name for 24 hours, and you must renew it in 12 hours. This DHCP server has basically has basically assigned you the IP address. And by the way, it is now this client's responsibility it is this client's responsibility that before you accept that IP address, it is this client's responsibility, by the way, to confirm if the IP is unique or not. So this client will also, the client assigns the IP on the network interface card, this client will also send the GARP, gratuitous ARP 3.3, trying to find out whether this IP is unique or not. No reply for those GARPs. That means, that IP is unique, so I can configure that IP address on my interface. No duplicacy, no duplicate message, nothing here. If the client is trying to configure the IP 3.3 on its net interface card, but for that, it first sends the ARP request to find whether this IP is unique or not. And let's say that the server was able to find some same IP address configured somewhere. If the client finds that IP address to be duplicate, that this IP address is already configured, understand that the client has the right to not assign the IP address on the interface.